In this work, we present GenSim, generating robotic simulation tasks via large language models. In robotic simulation environments, prior works have generated massive amounts of rollouts in parallel to train policies and have applied domain randomizations to create diverse scenes. This helps with generalizing over initial scenes and robot states. However, we are still missing the task level diversity, and thus our policy usually cannot generalize to new tasks. For instance, a robot that can stack a pyramid might not be able to stack a tower. Therefore, we propose GenSim, a LLM framework to scale up simulation task diversity for robotic policy training. Given natural language task descriptions, for instance, can you generate a task build a car, LLM can be used as a task creator to generate the corresponding Python code. So how does the Python code look like? In a typical reset function, we will load the objects, and then we will randomize the initial object poses, and then we will set the goals of each step. This new task class can be used to generate demonstrations. The generated code will be executed in simulation engines and checked through various feedbacks, such as simulation feedback, as well as self-reflection. Does the code implement the task correctly? And many more checks, such as single-task policy training. Now, this task build a car can be put in the task library, and by distillation and retrieval methods, it can potentially be helpful for creating future tasks. We can bootstrap iteratively and prompt the model to create different tasks. The final task library can be used to generate the actual task demonstrations to improve policy training and achieve sim-to-real adaptations. Let's take a closer look at the generated tasks. The initial task library has tasks such as place blocks in bowl with different colors and block insertion. Interestingly, GenSim can generate compositional tasks such as color order insertion that insert blocks into color fixtures. Bootstrapping from these tasks, GenSim can even extrapolate to tasks with hierarchical structures, such as ball on box in container, and tasks with multiple subtasks. This GenSim pipeline can expand the original benchmark size by an order of magnitude with minimal human supervision. We conduct experiments on LLM task generation, multitask policy learning in simulation, and pre-trained policy evaluation in the real world. We first see how well different LLMs perform in generating robotic simulation code. The y-axis denotes if the task can compile and run and successfully generate demonstrations. We see that GPT-3 to 3.5 to 4 has an increasing simulation coding capabilities. We then fine-tune closed source GPT 3.5 and open source CoRL instruct 13 billion on the generated task library from GPT-4 and see an improvement through supervised fine-tuning. We qualitatively evaluate further cases for both CoRL and GPT-4 for this task. We observe that CoRL has ignored the palette completely and GPT-4 has got the order of the placement of these objects wrong. Now we see LLM can generate these tasks, but are they useful? We conduct multitask policy training with original clipboard tasks and GenSim tasks. For both single task and multitask settings, we evaluate clipboard task performance by adding 2, 4, and 8 tasks from GenSim. We found that with more tasks being added, the performance can consistently improve. We also found that when training on more and more tasks, the policy exhibits stronger and stronger zero-shot generalizations. These results demonstrate the scaling laws of multitask robot policy training. Finally, we conduct sim-to-real adaptations and evaluate the policies trained with GenSim tasks in the real world. The model trained on 70 GenSim tasks achieved an average success rate of 70 over 10 trials of 9 long-horizon tasks. This is over 25% increase compared to baseline that doesn't train on GenSim tasks. Of course, we have seen some limitations. First, the generated code still suffers from hallucination and a lack of grounding in physical and geometric details. In the figure, it tries to put a cylinder on top of a ball stably, and also try to push a box into a container. For future works, we have only explored tabletop pick-and-place task generation. Generating dexterous and complex robotic tasks could be interesting future directions. Although our work focuses on generating simulation tasks with LLM, our work is largely inspired by related works. Prior works have considered using LLM as instructions, reward designs and optimization programs, open world agents, and policy code generation. Please visit our website, check out the Gradio demo, or scan the barcode for more details. Thank you.